Now let's explore your TFT display. These images looks beautiful, isn't it? But you know how much time I've spent to get it up. To be frank with you, it took me months. Now why? When I just received my TFT display, the pre-installed demo works perfectly. I can see pages of graphics and buttons that I can navigate and move around pages. Light control works well. Aircon control shows various buttons, selections panel, so everything looks great. When I just started to play with it, it's just disappointment. A simple screen with ESP32 never show up, but instead, a shady images like this appear. This effect is the simplest example that I've tried with the Espressif SDK. I move on to other example to hope to display some text wordings, but it was flipped and wrongly displayed. Now I get closer to some handsome images, but it was all shattered. Well, this is not animal abuse, but something just wasn't right. Now, how to speed up the process? We can't be wasting too much time and end up no results. First, identify your hardware. In this video, we're making use of the common board as our ESP32 development environment. By looking at your LCD board, you can check whether your TFT is RGB or the SPI protocol. Then, choose an IDE. There are many available IDE with its pros and cons. Try to use something that you're familiar with. If you have nothing in mind, then follow our video to see what others prefer. Then, locate your specific TFT library based on your board part number. Now it's always better to buy from a reputable supplier who can provide you a full board hardware details. Otherwise, you may end up spending unexpected time to get things right. To further expedite your development time, there are readily available graphic library to be used. Now LVGL is one of the most popular with lots of supporting tools. Now there isn't any IDE that can be considered as the best, otherwise it wouldn't exist so many choices. Each has its own strong points. Arduino is the best preference among students. It's the simplest way to begin, but the weakness is that it may not support some TFT display. You may have to wait for library updates with new TFT versions. Moreover, it may not be suitable for complex multitasking projects. Platform.io is another user-friendly IDE, but it has limited ESP-IDF support. VS Code is the most used among developers. In our video, we will use it for our coding example. Lion is another strong IDE, but however, if your PC spec is low, it may not run smoothly. Eclipse is another choice, but it does not have full ESP-IDF support. So that's why we prefer VS Code. VS Code provides full ESP-IDF support. Whenever any expressive update, it can be directly plugged into the VS Code with a zero downtime. To get started with, download the VS Code from its official website. Then install the ESP-IDF extension. Subsequently, you will be prompted to download other relevant files, typically Java. Install your preferred ESP-IDF versions. Now why I say so? Because the latest may not be well developed. It's always better to download the versions 1 or 2 steps backward. Look for LVGL using your VS Code command palette and download it to your preferred locations. Finally, install install any example from the ESP-IDF example folder. Now this will ensure the project folder will have all the relevant compilations and setting files. Now let's have a sketch run through on SPI LCD. Now this video will not go into full details on the programming steps, and that will be available in the subsequent videos. Now first, define your SPI pass. For the SPI LCD, you will need to create a SPI pass. With this, you define your SPI pin configuration such as the clock in, the data in, and the data out. In addition, also the SPI transfer block size. Now next is to create an I/O handler. Now SPI control is not limited to only clock and data pin. You also require pins like LCD, data and command, LCD chip select, and other respective pins. You will also need to specify a callback functions when SPI transfer is completed. Now the Espressif new panel I/O SPI is a function for you to create the I/O handler. Now next is a panel handler. Now panel handler is like control to all the LCD functions. After creating the panel handler, all the LCD functions can be executed. Now LVGL programming deserves its own video due to its complexity. Over here, we will just have an outline of what is required. So first, we have to define a display driver. Then we will require a rendering buffer. Now, LVGL normally requires to define at least 2 draw buffers. Then we will come to timing. Now, LVGL flushing will require its own timing clock. This will be defined how fast the TFT screen will be updated. Semaphore is a kind of mutual task lock mechanism. Now this ensures no resources conflict, as LCD data flushing is quite a heavy task. Flushing operations will transfer the draw buffer content to the LCD buffer. So these are the steps in LVGL drawing process. Now RGB LCD normally also requires an SPI control. Now this is needed during startup to configure things like brightness and other control commands. So in this example, we are making use of the IO3Y SPI to handle this LCD I/O control. Now these functions handle SPI through either GPIO or using the I/O expander chip that was mainly used on the cover board. RGB control is a heavy task. The ESP32 have to send the entire screen pixel data and synchronize the line and frame data. Over here, we define pins like VSync, FaceSync beside the RGB data pins. With this, we will create a panel handler. So with the RGB configuration defined, we will create a new panel handler making use of the specific driver number that we're using in this project. So in this case, it will be the GC9543. So from there on, we're going to create a panel handler. So with the new panel handler, you can start making use of the LCD specific functions. For example, reset, initialize, right? You can be doing things like draw bitmap on this one. For more information, visit us at udemy.com. You will also get handsome discount using the coupon code in the description below. So hope to see you soon. Thank you.